As we're learning how to evaluate definite integrals, there's a little tweak we're going to make when we're working with substitution. Let's look how definite integrals play into the substitution method. The main thing we have to keep in mind with substitution is we have to change the limits of integration with our u. What's nice then is we no longer have to go back to x. Here's what I mean with a couple examples. Let's do the integral from 0 to 1 of x squared e to the x cubed plus 1 dx. On this problem, we can see if we take the exponent on the e and make that our u, it's going to become much easier to solve. And that works because du, the 3x squared dx, we can obtain what we need by multiplying by 3 and dividing by 3. And then the 3x squared dx will all become my du. So now we have the integral of the 3x squared dx becoming the du. And we're left with e to the u with a 1/3 out front. But we're also going to go in and change the limits of integration. The bottom limit being 0, if I plug that into the x, we get 0 cubed plus 1 equals 1. So the new lower limit is 1. Plug the upper limit into the u equation, and we get 1 cubed plus 1. That's equal to 2. And so now my new upper limit is 2. And so now I'm integrating 1/3 of the integral 1 to 2 of e to the u du, which is easily e to the u with a 1/3 out front, integrated from 1 to 2. Notice we don't have to go back to x because we can just plug in e to the second minus 1/3 e to the first, and we have our solution. While this is an exact answer, you can plug that in your calculator and get an estimated answer with a decimal. But the main point we need to focus on is how those limits of integration had to change when we did substitution. Let's do one more example. Let's integrate from 1 to 3 of 5 over 2x plus 1 dx. Here we see we can make the denominator equal to our u. U is equal to 2x plus 1. Then the du is going to be 2 dx. Well, we don't want that 5 there. Let's move it out of the way. Move it outside the integral. We need to get a 2 in there, so we'll multiply by 2 and divide by 2. And again, we're going to change the limits of integration by plugging them into that u equation. So we get 2 times 1 plus 1 to get our new lower limit of 3. And plugging 3 in, we get 2 times 3 plus 1 to get our new lower limit of 7. So now our integral has that 5/2 out front. The new limits of integration are from 3 to 7. The 2 dx have become a du. And we're just left with 1 over the u. Evaluating that, we have 5/2 times the natural log of u, integrated from 3 to 7. Well, we can plug those in to get 5/2 natural log of 7 minus 5/2 natural log of 3. And if you want a decimal answer, you can plug that into your calculator, or we could just leave it as the exact answer here. So with definite integrals and substitution, we need to make sure we change those limits of integration so we can plug them right in to our u equation. Our next video is going to look at how definite integrals are connected to the area underneath a curve.